Consider the wagon being pulled down the street. The wagon has a handle that's not vertical or horizontal, but at an angle to the horizontal. This means the wagon is being pulled up and to the right at the same time. A free body diagram would include this force applied and all other forces, as seen here. We have the force applied, normal force, mg, force of friction, and of course we show the direction of the acceleration. The normal force and mg act in the y direction, and the force of friction acts just in the x direction. But the force applied is a problem. It acts both in the x and y directions. So we need to separate that into components on the x and y axes. We need to use trigonometry. We create a triangle where the hypotenuse is the force applied and the x and y components are the sides. We're going to have to use the sine and cosine functions. So let's try an example. Now let's use an example where the force applied is 50 newtons and it's at an angle of 30 degrees from the horizontal, 30 degrees from the ground. First, we'll find the x component. So we need to use cosine. Now the cosine of the angle is equal to the adjacent over the hypotenuse. So if we want the adjacent side, we multiply hypotenuse times cosine of the angle. So that would be 50 newtons times the cosine of 30 degrees. So that x component would be equal to 43.3 newtons. If we want to, we can add that x component to our free body diagram so that it is only in the x direction. Now to find the y component, we'll use the sine function. So sine of theta equals opposite over hypotenuse. So to find the opposite, we take the hypotenuse times the sine of the angle. So that's 50 newtons times the sine of 30 degrees. So then the y component is equal to 25 newtons. Again, if we'd like, we can add that to our free body diagram so that that force in the y direction is along the y-axis. That force applied can now be represented by Fx and Fy components.